Good afternoon, folks. Here we are, kind of a second part of thermistor calibration. And with that said, like for example, uh, our last video show how can we do it using Excel correlations. You know, you go to Excel, like for example, you are right here, and you do a check and see obviously that you cannot feed all the data we want single linear regression, so you try to use as many regression you can, and you identify something like this. Again, all this was in the last video, and depending of the zone that you are, then that's the correlation that you will use. That's perfect. Then you go to your Arduino, and let's go to the Arduino 1 second here. And when you go to your Arduino, then like for example, every time you need to call for the temperature, this is a program, this is a process control, this is a PI controller implemented in Arduino. And before discussing everything that is there, like for example, you have to do this call to temperature just because you need to temperature in the engineering unit, so you do a call, this call. And when you do that call, then you go to your function that is at the end of this, and here's the function. And all this is kind of commented, or comment, I mean with the comment, just in the sense that I'm not using this at this point. I mean, I can use three different ways to do this, to come out with the engineering unit, you know, the calibration of my thermistor. In that sense, I can definitely use, like for example, if I have identified three zones, like for example, this is the first zone, and I use this equation. Then you go to an end if, so you don't want to go through this one again, and then you go to the second, if to a third one, second, and these are the three zones that you can definitely write it, you know, come out with them through Excel spreadsheet, and that's perfect. How about if your ADC or your number coming from the Arduino doesn't fall in any of the zone? Means that I probably have an overflow or something weird going on, like I'm in the extremes of the range that I can use. So I use this concept dividing by 0 here just for the fun of it. You know, that will cause some trouble, so you will know that you are totally out of spec within the range. No problem. Now, if you want to use a single correlation, like, you know, like this one, this PV, you know, it takes the value from the ADC, that's a 0 to 1023, and through all this equation, and this equation obviously, so this is the equation that you generate with a correlation of a polynomial for order 6. So you get pretty much the whole data in one single equation. You can certainly do that. Still, there's some differences that I don't like, above 1 degree in one particular region, particularly the high region here. I got about 4 degrees off from what I would like to see. So, but again, but the correlation is pretty much, it's pretty good from 100 down to minus 16 or so, which is the max, the lowest range on this data, and that's okay. I mean, it makes sense, except for the high region. That then again, if there's a region that doesn't fit your data, then that you need to use a different correlation, and that's kind of beat the fact that I want to use only one, so you will have to use two, and that's the part that I don't like. All right, but it's okay. I mean, this is a way to do it. There are people that go crazy about it and do sick correlations. You know, like they take this small segment here, they take another small segment here, they take another small segment here, and you go through taking a small segment and so forth. Well, that's okay. But if you want to take this data and break it segment by segment, you know, kind of small segment, you might as well do what I call a lookup table, because that's crazy. breaking all this by a small segment. Just use the data the way it is, you know. Like for example, this number 840 is not data. It's not a data point. 840. If you come out with this on your Arduino, the question is what's the temperature? So you have to interpolate between the 824, the 862, and the 80 and the 70 just to get this number right there. See, what is the number there? You have to do interpolation. So you might as well do that within the Arduino and get all this done. All right, so that's what I will do to get this going. I just put those sign there, and the curve kind of got weird very quickly. Oh well, so get those out. Anyway, so the idea is that one. So you can do an interpolation table, you know, using what I call it a lookup table. By how I do that, then it's very easy. Let's go to the Arduino 1 second, and let's go to the code in the Arduino. In the Arduino, you just need to do these two arrays, one for temperature and one for the ADC, the analog to the digital converter. Like for example, 952 is 130.1 degrees C, 945 is 120, and you keep going. And I think that I got about 23 point here within those two arrays. Okay. Did I put, did I wrote this directly? No, hell no. No, I use Excel and few tricks here and there, and the tape and this number, I got them right there. Very simple, but I will show you that later. Anyway, so I got those array there, and one for temperature, one for ADC. Now, when I call for the function temperature to provide a number, so as you can see here, I commented everything else that I'm not using. I can use it, but not at this point. And I commented the 3-zone section, the single zone section. I only leave this on. So the lookup table is on, so it's working. Now I have here a 4 that is checking from the highest number to the lowest. Be careful there, because the way I set up the table is the way I got the data. The data was from the highest value to the lowest value. So when I'm doing the testing here, where my value, my PV, which is the analog value coming from the Arduino from 0 to 1023, where it fits, is less than my highest value, but not to the other next value. So if it's within this range, then I used to have some serial print here just to be sure that the number is being, you don't need those serial print there. You need this. And here is the interpolation equation. Straight the way it is, I'm not, you can go and deep check yourself where this equation come from, but this interpolation, you go to Wikipedia, for example, and you will find how to do it. I just put it right here, I can show you what it is in a second. You give me a second. So the idea is, again, all these serial prints, I took them off. They're not needed anymore. But at the end, you go to, why you go to this end if all of a suddenly when you are with, basically, I want to break out from the 4 and from the if, but basically from the 4. This is a nice way to break from the 4. When I do this, go to end if I got my ADC where I want it within the range of 2 numbers, then I don't need to check anything else. I just pull out from there with this go to end if. I go to end if. I got this here because somehow it's necessary for the compiler, because when you pull out from here, there's a lot of stuff that get kind of hang up in the Arduino, and this kind of settles them. PV equal PV, I'm not doing anything. I break here. So this one actually, the one in this one here, close the one at the top for this function, this one here. And when that is done, basically you get the value, an interpolated value, and then you go back and present that value where it should be. And that's as simple as that. No correlation whatsoever. You use the data the way it is. And I kind of like it. Extremely, straightforward to do that. So let's see. Let's download that to my controller, Arduino controller. It tends to be a little bit higher on memory. I would say like a 3% higher than what it used to be on the global variables. But it's okay. Now let me do this, and I can definitely turn on my camera, but I will not do that, not at this point. So I'm gonna push the button. There's a push button here. It's just to start the PI controller, and there we go. So you get the time, the actual temperature, and how much you need to do, how much cold water you have to add to your hot water just to bring that within temperature of 25 degrees C. The time here is every 30 seconds. This is 30,000, but this is milliseconds, so I better right here the unit. This is 30 seconds, and it prints every 5 seconds until it hit the 30 to let you know that you need to again add 3.83 mLs of water to your hot water. If I take the sensor in my hand and heat it a little bit, so the temperature will go up, and so the amount of water that I need to add, like for example right now it jumped from 29 almost to 33, 34, kind of hitting the tip of the sensor, and now it's calling for adding the maximum amount of water, of cold water, which is 10 ml. All right, so that's how this works. Now, the data that I got from for this thermistor is from somebody else. It's not my data. It's not my thermistor. So every thermistor needs to be calibrated for the range that you are working on. Now, what happens if you are out of the ranges? Like for example, on my thermistor, let's see, the ranges that I have from the data that I got is this. Let's go here. Like for example, what happens if the ADC go, I don't know, like 1023, a number higher than 952? Well, you gotta write code for to handle that. Obviously, you will have something kind of weird. The same will happen if your ADC is less than 131. You see, if you are beyond those limits, then you are not doing interpolation anymore. You're doing some like extrapolation. So that would be something else. I haven't add any code to do that. For example, why not? Well, I don't expect anything to go above 130 degrees. On the other hand, I don't expect anything that go below 16.6, negative 16.6 degrees C. See, so if I don't expect anything of that to happen, then I haven't add any more code to it. If you expect something weird like that happening, then right here somewhere, here, if this 4 got completed, like go to the, I got 23 points, but since I start in 0, then you got from 0 to 22, then you will have to do something. Like for example, no matching was found within the range, so you might divide by 0 just to indicate that there's something weird happening. That's one way to do it. In fact, I did that right here. If the number is not within the 3 zones that I want, like for example, I divide by 0 here, that will, cause some commotion, and you will have to look at what's going to happen with that. I mean, that's one way to do it. Just, to entertain the situation that the number, the ADC value that is coming from the Arduino cannot be correlated to any temperature. Okay? So for the single equation, you can do the same. But now, in the single equation, that's interesting. The single equation, I just plot whatever PV come from the ADC, and it will provide a temperature. If the temperature is outside this where this correlation was good, which was basically from -16 to 100 degrees, it was pretty good. It was plus minus 1 degree. Now, if you go above 100 degrees, you can have errors of about 4 degrees C. See again, you know what I'm saying? Like, you, depending on what region you are, you want to be careful, like, you know, for this correlation. Where in what range is the data is really good. On the lookup table again, it will be perfect. I mean, this, I think that this is even better than anything else. But again, the ranges are the way they are. You cannot go above or below, because then you are totally on your own. You know, you got to do more code of what I have here so far. But this will work. I mean, again, I'm not expecting anything below 16, -16, or anything above 130. So this will work okay. Now for the interpolation, I know that there's some question about that, and there's also questions about how I got this data here without even, you know, putting my hands just to do that. Basically, let's start with this. Just to get the data there is as simple as this. Go to your Excel table. In your Excel table, like for example, this is the ADC data and this is the temperature data. One thing that you could do is, I mean, this data was sent to me by a student, so you just copy that data up to here. I copy that data and I paste it. The first thing that you want to do is to kind of a transpose on the paste. So do a special transpose, and now the data is sideways, which is what you wanted, and right, just to get it. I'm close to get this into the Arduino now. So the next part is copy that up to here, copy, and now go to Word, your editor, and so let's do a new here, just so you know what I'm doing. And when you paste it here, paste the text. Okay, don't worry about it the way it looks like. It's going to be fixed in a second. Now that's the data from the highest value to the lowest value. Now tell Word that you want to change that space. Tell them that you want to change it to a comma. That's it. Replace all. 25 there. Okay. Let's see what I got. Looks, oh, yeah, that will do. And let's see. Yep. So now I copy that. Let's see if I can get this one. Undo. I deleted something I don't want to do. Let's copy all that. Copy. And now let's go to. I think that I have more numbers here. Let me go back 1 second to Excel, because I think that in Excel I had numbers that they're not the I was doing. Yeah, like for example, that's the story. I have this number here that it shouldn't be there because I was kind of testing some interpolation values. So let me delete what is not supposed to be there. That one is not supposed to be there, and this one and this one. Those are values that were not supposed to be there because I was doing some simple interpolation. I'll just repeat again what I just did. Copy. And now put that back here. Paste. Space spatial. Transpose. Now we're done. Now I copy the last line here. You have less value than the one above. Yep. Copy. Now go to Word and do a text. Let's see where I have it. Let me go and undo so I can do it again. Let me do a paste text again. There we go. The 952, the 945, the 936. Yeah, perfect. I can delete the one that were not there, but I don't want to massage the data. I just want it the way it is and let the whole system deal with it. So that copy that space. So I want to replace it with a comma just to be sure like that. Replace all, and now we have 22 values. Perfect, excellent. That's what it's supposed to be. So I got the 22 values there. The next thing is just straightforward. Just copy that data. I mean, I'm doing this. I mean, 22 values not that bad. I mean, I have seen correlation that goes, you know, 100 values. If you had to copy 100 values, I would not do that. In fact, I was even refusing to copy 22. Can you imagine doing 100? No. So I copy that. Now I go to Arduino, to my IDE here, and like for example, you can put it anywhere here, and you know, just for the sake of the argument, I'm doing the ADC. Let's put it here, and those are the numbers. That's it. You square them with this, and you add whatever is missing, like integer, my ADC, and equal to that, and those are the data that you have at least from the ADC part. This is the analog to digital converted, which is a number that goes from 1023 down to 0. So, but in my table goes from 952 down to 131. I repeat the same with the temperature. I do the same stuff with the temperature side. Now, the only difference is that this is float because this is decimal places, but this one is integers. No problem. The other stuff is just doing the interpolation, and let me show you that. Let me delete this. I don't need this anymore here. That I was just demonstrating how can you do it very easily. Now let's see. The only thing left is just to go to OneNote here and show you a little bit of about interpolation and how I'm doing it. Like for example, I remember a number. Let's see. I remember a 952. Let me go to Excel 1 second here. So 952, 945. Actually, you know what? I'm up to not to write too much copy. So let's see. Let's go to my OneNote here, and let's put those numbers somewhere here. And let's see. Kind of tiny. I can make the bigger as if I can see it. Let's see if we can grab it here. Well, actually, I need to increase the font. That's the problem. I need to increase the font. No problem there. So I see the numbers. So anyway, so it's 952 and 945, and the other number is 130, and this is the Lookup Table, right? And let's say for the argument that I have here 130.1 and 120.1, and here is the value that the subroutine or the function is looking for. Like for example, let's say that I have 946. So I have a value of about 946, which is just a little bit higher. I say 47. Or it could be anything. I don't care. 947. The question is, what is this value here? Can I do a quick interpolation? And the answer is yes. Very simple. This is how you would do it. Take this number, the 947, and subtract the 952, and divide that number by the 945 less than the 952. See? And that has to be equal to this number that I don't know what it is, less than 130.1, the same order, don't change the order, this one minus this one. So it's going to be 120.1 minus 130.1. All right? So what's going to happen is this will be a number. Okay, let's number that kind of slope just for the sake of the argument, and multiply that by this difference, 120.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. 1 20.1. minus 130.1, this difference here, and then you add this number. So the final question, the answer here is 130.1 plus this number multiplied by this, and this is your final answer. All right, and that's how the interpolation will work. The very important aspect of it is that you have to locate your value coming from the Arduino somewhere within the table, at least for the ADC part, which eventually will help you to interpolate for the temperature side. This is ADC, this is temperature, where ADC is analog to digital converter, which is the ADC is just a value that will go from 0 to 1023. Okay, now let's finish this, because I know that you want to be sure that the temperature you're predicting here has to be between these two values. I mean, there's no way around. So let's do that. For the sake of the argument, I'm going to copy this, copy, and let's go to Excel. 1 second here. Oops, Excel, and let's move this a little bit there, and let's put this. Actually, let me paste special. That would do. I'm coming from OneNote 10. There we go. There we go. So now, OneNote again. The value that I was looking is 947. So that's the value. Let's do it right here. This is how you would do it. 947. Let's open here and let's write 947 here. There we go. The question is, what is this value? So equal. Let's do what I did back on OneNote. So the first thing you will do is this value minus this value divided by this value minus this value multiplied by, now here's the question, is this value minus, which is, I'm doing this part here, 120.1 minus this value, and then add this value, the 130. All right, let's see what happened. 123, which is perfect, basically 123, that's the value. This is how it will work. That's the value that is interpolated from the 120 and 130. I can change these to any value, like for example 948, which is going to be 125, pretty much in the middle of it. 149, 949, a little bit higher than the middle, but that makes sense. See what I'm saying? It's very straightforward to get the proper temperature without curve fitting or doing any correlation. It's just using a lookup table, and this is what you are doing within the Arduino, doing this interpolation when I get the proper ADC. Remember, this table go from the highest value to the lowest value. Some table will go from the lowest to the highest. Be careful what you do, because that definitely will affect the way you do the interpolation. I don't think that I have to say anything else about this. It's just straightforward. Let's go to one more to the Arduino just in case. And again, this concept here is for a lookup table. I don't know why I put that there. Should put it here, right? Because those are for my lookup table. There we go. That's how I do lookup table. I just put my data in an array, to array, one for the temperature, one for the ADC. And when I call, anytime I call for temperature in this PI controller, like for example, I call for temperature here. Actually, I call for temperature. I think that it was. Let's see. Here too. I call for temperature here. This is for time 0, for t equals 0. This is the first call for temperature. I believe it's this one here. Yes, that's true. Correct. Because this is in the voice setup, which is executed one time only. Yep. So I call for temperature there. I call for temperature here again. Now here I'm in the loop. I might call for temperature time to time just to print some values, see how the temperature is looking. And that's it. And basically, and when you call for temperature, you go here to the function and you execute whatever you have here available, either full correlation, many zones, 1, 2, 3, 4, whatever you want to do, or you go for a single correlation like this one, or you go for a lookup table. Again, I haven't added any more code to protect the limits. I don't expect to get into the limits, but that's something that you could certainly do. If you expect above or below the limits, then do what you have to do. I will say up to here that this is it. I mean, this is a kind of a caviar for your thermistor calibration, how to handle that within the Arduino. I'm handling this just because I put together this code, which is a introduction of a PI controller. This PI doesn't have the anti-wind up. That would be something else that I might adding in the future, kind of an anti-wind up. I mean, at this point, it's just you just put the constant that you want. Like for example, what's the value of KC? Let's see if it's here somewhere. KC, proportional constant, -10, and the tau e for the integral parts, 600,000 milliseconds. Remember, I'm using milliseconds on this code, so because I'm using the instruction millis for the intervals, see, and also I'm using 30-second cycle time. Again, let's go with there's a theory behind all that. There are videos that explain this what I'm doing here a little bit better, but again, this video was only for the thermistor and how that data can be then analyzed within the Arduino, so you get proper temperature in the correct unit. Well, that's it, folks. Have fun. Bye.